Chetan, I'm the host now. Oh, and people are coming. We're 17 now. We can start whenever you want, Chetan.
Okay, sure. I'll start now. Yeah, good afternoon, evening, morning to everyone. I am Jason Duffman. I am one of the co-chairs of the Ocean Best Practices Task Team for Coastal Observations for All, or formerly called Coastal Observations for Under-Resourced Countries. My other co-leads are Lucy and Tommy, who will both be presenting in a few minutes. Yeah, so I'll just give a little bit of introduction to why we're here. So, how does this work? Yeah, so we are here to have a discussion about coastal observations. We want to discuss approaches that are fit for purpose, robust, and are frugal in terms of both energy, raw materials, and finances. So the key objectives are to develop or identify approaches that are both low cost and low tech, and can be used in a wide range of applications. So the three conveners for today is myself. I work for the South African Environmental Observation Network in South Africa. Lucy, who is at Ifremer in France, and Samuel, who is an early career professional, and he's in Ghana. Yeah, I don't know if, Lucy, do you want to just introduce yourself, or you want?
Oh, I can do that quickly. So I'm Lucie Cocampo. I work at Ifremer. Ifremer is the French Institute for Marine Research. My job there is to coordinate ocean observing systems, and my passion is to connect different people who share common interests and make them do great things together. So I think that's it for my motivation for the day.
Yeah, I can't see who's in the, is Samuel with us?
No, I think Samuel has some trouble getting through the connection process, so maybe we can start without him and with Jen eventually.
Yeah, so yeah, the scope for the discussion today is, yeah, we are, as I mentioned, we are trying to identify methods or approaches for observing the coastal environment. We have a wide range, we're focusing on a wide range of disciplines, all the way from physics to biology, chemistry, and sediments. We are focusing on any essential ocean variables, but what we'd like to discuss is exactly which essential ocean variables you might be interested in, because there is quite a wide variety, or quite a big list of variables. So it would be good to try and narrow these down to the important ones for you. And yeah, we have quite a, yeah, we like I said, we are focused on low cost and low tech instruments, but they can be from any sort of platform or sensor. So yeah, discussions around all of these will be very valuable for us. Yeah, Lucy, I don't know if you want to go through the housekeeping.
Yeah, I'll share my screen, but while I'm doing that, maybe you can go to this website we prepare for this event, and I'll share my screen with the internet window.
I'll stop sharing mine.
Yeah. Okay, so now you can see my messy desktop and stuff. Let me get rid of those. So yeah, because we didn't know what to expect with the Kiko Chat platform, we just thought that we could build a small website for this event and for others, because as Chetan will tell you later, we're starting to build a community here, so we'll be attending many events. So this website has been designed for us to have a community, to get the sense of joining together. So as you can see, it's quite simple. And if you click here, we invite you to provide and share information about you, so we can get to know you better. So it's quite simple. You know, you have this very simple form you could fill during this session. So at the end of the session, hopefully you will see that our community has grown. And then you have, from the top menu, you can see you have search for resources. So here, if you click on that, you have a glossary, because it's very important that we share the same basic knowledge and information. So you can search for a term. We put some definition already in it, but if during this session there's a word, an acronym that you don't know, you can add a new entry here. You put a question mark if you don't know the term, and then, I don't know, like DMP, this is data management plan. But if you don't know the term, you put a question mark before the term, you submit, and then I'll see it, and hopefully I'll try to find a definition for you. And if you see here that there's a definition, but you're not happy with it, feel free to modify it. This is like co-designing our knowledge together. So this is for the glossary. Here you can search for documentation, and yeah, we put a link to the Ocean Best Practice data portal, which is really good. And here you can search also for initiatives. We put some initiatives for under-resourced countries for everybody who wants to observe the coastal ocean. So here you have 2 examples, but you can add more. We will be really happy to have your initiatives in this portal. So feel free to send some information, like the name of the initiative, the contact, some details, maybe a picture and an attachment. And then that will be it. So this is for resources, and then this is for you to share information. So if you have an event that could interest us or as a community, then feel free to add an event here in the calendar. You can also share your experience by filling this survey, this Google survey, but maybe we'll go through it during this session. Okay, so the first thing we would like you to do, oh, and I can see Tim's picture, nice, is put your profile here. Okay, I think that's it. I'll put the link again, and I'll see at the end of the session if we have people who have joined our community. Jetan, I think I hand over to you for a quick presentation of our task team, right? Because yeah. This is a reminder.
Yeah, so just a quick introduction to the agenda. We're doing introduction and welcome. I'll go through the task team, introduce the task team now. Then we'll have some presentations about some initiatives of some low cost and low tech approaches. And then we are hoping to have quite a fruitful discussion about these initiatives and just things that we need to start addressing and highlight. And then we'll have a wrap up. So we are a task team we are the Ocean Best Practices task team for under-resourced countries. It's led by myself, Tommy Bornman, and Lucy. So we started in January of this year, and we are trying to identify best practices for coastal observations, particularly for under-resourced countries. Many countries and institutes face fundamental problems with access to equipment and expertise to monitor the coastal environment. And these problems are kind of exacerbated by the lack of best practices around the ocean community. And so we are we've been tasked to start developing or to identify these best practices and publish them on the Ocean Best Practices repository for everyone to access. Yeah, so our objectives are to develop a manual for these best practices and publish them and spread them around so that everyone can have access to them and start observing the ocean with the confidence of knowing that their methods and their approaches are recognized internationally. Yeah, so like I said, we started in January of this year, and at the moment we are in a community building phase. So that's partly why we're here, is trying to build our community. So if you could please just add your profile to the website, we'll then be in touch, and we can make you a part of the community and share our reports and any findings that we have. And then from sort of next year onwards, we'll be producing these reports and these manuals. So we also have another website. It's just for access to any of the information that we create or share. It's minutes from our meetings, it's presentations. I think the presentations are also uploaded onto the website Lucy showed. You can access our proposal. You can access the repository. I think, so all the information is very similar, but there's some small differences. I think that's it from me. That was a very quick overview. If there's any questions, please, this session is very interactive or relaxed. So if you have any questions, please feel free to ask. Just to quickly introduce our speakers. So we have Cedric, who's going to be talking about open source technologies. Then Tommy Bonwin will present on South Africa's observations, as well as 2 initiatives called CoLab and Gem in a Box. Then Shirley will present on low-cost or low-tech benthic observations. And then we have a pre-recorded presentation from Carla Edworthy on ocean acidification. That's it from me. Cedric, do you want to?
Yep, I can start if it's okay for you.
Yeah, thank you.
I try to share my screen. Do you see my screen?
Yes, we do.
Very good. So thank you. I'm Cedric Courson. I am actually a PhD student in University of Paris, and I work in 3 laboratories between Paris and Brest in France. It is an interdisciplinary subject between classical oceanography, engineering development, and human and social science. I am also the president of the NGO Astrolab Expedition that aims to develop citizen science program for oceanography. As you know, the ocean is a bigger part of the Earth. And the ocean is very important for Earth because there is the largest ecosystem, because it is the main temperature regulator with its currents. And for food, and because people live near the ocean, it is very important to know the ocean and to anticipate its evolution, particularly with the climate change. in my research, I am working on opportunity and program and research action participatory program for a frugal oceanography. I start to show you some opportunities to develop a frugal oceanography. The first one is open source methodologies. Open source is an opportunity to reappropriate the measure. Open source means that all the source and all what we need to develop something is open, and all people can discover the sources and contribute to evolve this work. It's a very good way to manufacture, repair, and maintain instruments, because we know exactly, it's not a black box. We know exactly what they add in this instrument, and we are able to repair it. It's easy to control metrology. Obviously, the instrument is very modular. You can control the cost, of course. And it's an opportunity to, at the end of obsolescence, because thanks to the community, there is a constant evolution of the instrument, and the instrument will never be obsolete. Another opportunity is low-tech philosophy. Maybe you are familiar with the subject. And low-tech philosophy is globally, we will do only what we need regarding the local resources. And it's very important to have this philosophy when we design something to be sustainable. And to be sustainable is very important to have a more resilience method in the condition of climate change. Another big opportunity is citizen science. Maybe you know what it is, but just a little definition. Citizen science is a way to produce knowledge, scientific knowledge, by involving non-professional scientists with scientists to work on a project. So it's a collaboration between citizen, non-professional, and professional scientists to produce knowledge on a subject. And it is very important to keep in mind that it's to produce knowledge, and you can involve citizens in the many parts of the project. Involving citizens is very important to take research to a larger scale. Because there is many citizens everywhere in the world. They live on the field, they are on the spot. There is more important thing is there is variety of type of players. There is a citizen, NGO, public institute, marine area, cities, and that is important to. Because there is a big community and because there is a lot of point of view, it's a good way to innovate. And all this community can be involved in different steps of the program. All just to imagine the potential opportunity. That is map of citizen Fab Lab in the world. It is citizen laboratory like Fab Lab, Hackerspace. In all these places, we can find the same tools and the same, and there is the same tools in a place, and there is a big community in each place and a big know-how in each place. So if you design something in one of these places, you can be sure this thing, methodology or device, can be reproduced in any space in the world. So it's a big opportunity to to develop and to reproduce something at a larger scale. And about seller teams, this number is cool too, because maybe you know that there is only few between 1 and 200 institutional scientific bots to go in the IC, and there is 12,000 selling bots every year in the IC, and millions of pleasure bots in the coastal environment. So there is many bots, and if you can imagine if each bot become a platform for oceanography, it's easy to imagine the potential development. All these things is okay with the concept of frugal innovation. It's doing better with less. And we can do with this all opportunity, all methodology, go toward frugal oceanography. I will show you now how we work and 3 programs on which one I work. This one is the global methodology for our citizens science program. In this methodology, citizens are not involved not only as prone sources data. All citizens are involved in each part of the project. For example, citizens discuss with scientists to define the protocol. And the seafarer, the user, discuss with scientists to define the protocol. And that is very important to imagine a protocol and a tool which is adapted to the user. After we go in the Fab Lab, when we have a protocol, we go in the Fab Lab to work with the different community to develop the tools, the device we need to do the protocol. And after, we go in the sea with sailing boat to collect data. And this data, even for data analyzing, we include citizens for analyzing. For example, we have a program to analyze the sound of waves, so citizens can listen sounds and identify if it's a wave or not. And as you can see, in this program, each citizen can be involved on each part of the program. The first one in which I work is Sense Ocean, is a program for study the salinity of the surface of the sea. This is very important to understand the relation between sea and atmosphere, and to understand how the ocean can regulate the climate. This device is developed is manufactured in Fab Lab, and it costs only 700 euros, and we can collect temperature, salinity, air pressure, GPS, and it is fully autonomous thanks to the solar panel. This device is actually on 12 boats on the sea. The boats are in Atlantic Sea, Pacific Sea, Mediterranean, and North Sea, near Greenland, Iceland. And they collect data, and it's working very fine. And the program is actually in prototyping, and it's cool to see the data. And we think there is a good potential to have a good data. Another one is LITOPS. It's for salinity gradient in coastal environment. In this program, we will develop a prototype in Brittany to understand how the continental water, the river, is mixing with ocean water. That is very important because the river brings many nutrients, and thanks to the river, there is a big ecosystem just next to the connection between the river and the sea. So it is important to monitor the parameter of this coastal environment. And for that, we developed this little CTD for temperature, salinity, and depth. And citizens go on the bay, on the coastal sea with this device. They drop the device into the water. And after 3 or 6 months, they return to the GPS point, take out the device and collect data. And that is a great opportunity to collect data in 3 dimensions because there is many sensors in different depth to understand in 3 dimensions the current and or many parameters. This program is actually we will deploy this device starting this winter in south on Brittany. This program is a collaborative program with marine areas and cities and Sailor Research Institute, and we will have many data in next years. And another one is Open Lagoon, is a program to study many parameters in the coastal environment. In this one, you have temperature, salinity, pressure, and chlorophyll and turbidity. It is a multi-parameter device. And this device is actually deployed in, the first one is this one, in Senegal, in the Bay of Senegal. The problem is we see that fishermen have, the fish is decreasing since few years, and we don't understand why. So we have to deploy many sensors to monitor what is going to happen with the fish. And actually, there is 3 devices in Senegal, and this is the data of this device. And starting in right now, there is a device in Tahiti and many lagoons of Polynesia. In Polynesia, the problematic is to monitor and anticipate the bloom plankton in the lagoon, because the plankton is the food for fish and pearl, and we have to know how the bloom is evolving and how the food is evolving. So we need many sensors, we need many data. So open source technology and citizen involvement offer a good way to have this data. Just one word about open source oceanographic system, because in these 3 cases, you can see 3 devices, and these 3 devices share the same architecture. So it is the same instrument, the same. It's like a Lego. You have the brain, and after you can plug many sensors depending of what you want to study. And with this open source oceanographic systems, we have a system of device and citizen science method to study many things in larger environment. Thank you for your attention. And if you have questions.
Thanks a lot, Cedric. Yes, we have a question from Carla in the chat for you. Carla, do you want to open your mic and ask the question yourself? Or I can do it for you. Carla, yeah.
How can you get in contact with the Citizen Laboratory Network?
Carla,
Yep.
Carla, do you want to develop your question? We can't hear you now. We could hear you. No?
If I understand your question, Carla, if you can make a sign, it's
Yeah. Oh no,
no.
it goes on and on.
It's about how to work with Fab Labs.
Yeah. I think she's writing in the chat, but
Yep. Okay.
I think you got the idea.
Yeah, I see your question. And if I understand, it's how can we work with the Fab Lab and can maintain the Fab Lab is an environment where there is many tools and many communities, but Fab Lab is not like a society. They don't develop something for you. It's an environment where you can work and discover and have many help of many things. Oh, okay. In Argentina, I don't know, but I'm pretty sure you can go in the Fab Lab, present your subject, and if you abord the subject like a challenge, like for the people of the Fab Lab, they will be happy to try to find a solution for your challenge. In the Fab Lab, there is many people who like solve different kind of challenge, and they always be happy to share competencies and tools to respond at your problem.
And Cedric, if you let me add a few words, there's an international association which is called Maker North South. And this is an association of Fab Labs from the Northern Hemisphere and the Southern one, and they try to foster collaboration between the two. So I can put you in contact with this association and maybe with a Fab Lab in Argentina if you need. I saw a question from Jay Perlman. You had a question for Cedric?
No, I don't. I'm just listening and enjoying.
Oh, you were just waving.
I was saying hello.
Saying hello. I have a couple of questions for Cedric then. Cedric, you mentioned a program in Senegal, and when you were referring to it, you said we, and I was wondering, who is this we? Do you collaborate with communities there, or is it like parachute science? You go with a French team and you go do your study? Could you develop this point?
Yeah, it's the IRD Institute and the laboratory of FEMAR. It is the NGO Astrolabe Expedition, and it is my work in PhD. And it is a Fab Lab of Brest. It is also the community of Senegal, because in Senegal there is people who depend of the fish to live, and for example, in this case, the researcher Johan Thomas, he works at IRD. He communicates with the women and the men, because men have a boat and go to the sea to make fish, and women are on the sands to search to make fish in sands. And the people of the village are involved to survey and maintain the instrument in the local population. And for the we, I think it's a response to the question.
So you work with the fishermen and the lady from the village, right?
Yeah.
Okay. Sarah, you have a question?
Yes.
Please open your mic. Yeah, we can hear you.
I wonder if you have published any papers regarding the comparison between these sensors and traditional ones. That's the question.
Okay, I am working on this kind of paper. There is many paper about if you want some reference about comparison between temperature and salinity sensor open source compared to professional like YSC. I have one on two reference I can share with you, of course. And just one word, keep in mind that open source instruments that not aims to remplacer the traditional instrument. It's complementary tools. For example, I use traditional instrument like NKE, RBR, which is very expensive, in a few points, but it's impossible to have a big spatial resolution with expensive instruments. But you can use both. In some point you have expensive instrument, and in many points you have a low-cost instrument, and you can recalibrate the data of low-cost instrument with expensive. For example, you can see the work of the Minky project that aims to qualify low-cost data with data coming from expensive instruments.
One last question, Carla. You had another question?
Hi, do you hear me now?
Yeah, much better.
Cool. I'm through my cell phone. So Cedric, nice to meet you. Really nice talk. Sorry I couldn't talk. I just have two questions in one. First, why not consider also divers as citizens science? For example, in our country, we are running a time series. It's been 4 years, run by divers, and they're like really human cool Niskin samples bottles that you can really use, and they can really take small CTDs or even, I don't know, divers computer where they're not maybe climate quality, but at least weather, and they can feel like you can sense the changes in temperature at least, or collect samples, discrete samples for salinity. This was my first comment. What do you think that we can include also other members of society other than boats or citizens divers?
Yeah, yeah, it's a good point. There is many divers around the world, and we can speak about yeah, some different kind of program where divers is involving. I think about a program of global biodiversity inventory. It's easy to divers to take a photography and make an inventory. And I think about a coral program where divers go in the program. And as we see with the divers is in many cases very happy to help, and it's a great opportunity to have the divers as will be happy if sorry for divers make scientific data is a good opportunity to dive, and use the instrument of the divers like computer divers. I think is not very good because in many cases we don't have the good quality of sensor in the computer, but it's easy to plug a CTD just next to the bottle, for example, and for each dive they have many good data. If
Many
you
thanks.
are interested, I can share you some program citizen science with divers.
Definitely, really appreciate. Since it's been 4 years since we're diving. I mean, no, I'm not diving, but we are in a program with divers, and we're really interesting to focus in other part or to contact with other divers on other citizen science activities in the ocean and other part of the world. So many thanks.
Okay, thanks.
Yeah,
One
thanks,
example.
David. Sorry, Lucy.
No,
Thanks,
no,
David.
you go.
Tommy, are you ready to present?
Yes, I can.
Over to you.
All right, I'll just share my screen.
Yeah, you should have full access. So.
Okay. All right, you can see my slides, Jason. All right, thank you everyone for attending this session. I'm going to give a brief overview of coastal and marginal sea observing instrumentation in under-resourced countries. And just to set the scene, if you look at the global ocean observing system map of moorings, you can see a very big gap here in Africa and in quite a few of the island states. And the same for another network, the International Long-Term Ecological Research Network, who has 130 sites registered on the DAMES database. And you will notice once again a massive gap in Africa and the island states. If you look at the Data Buoy Cooperation Panel list of moorings, again, only Reunion Island has got a mooring, very big gaps in Africa and most of the island states. But surprisingly, the Global Sea Level Observing System, GLOS, you can see a lot of instrumentation in and around Africa. So what are they doing well compared to the others is that they are very well organized and have created a community of practice with buy-in from all the different countries. So does this mean that there are no coastal observations taking place in Africa and in these island states? Definitely not. Just as an example, this just shows you all the coastal observations in South Africa alone. So there's a lot. And from our workshop that we held as part of the task team in Maputo earlier this year, we also heard from Mozambique and Kenya and Seychelles and many other under-resourced countries who has developed, quite comprehensive observation systems in their own countries. But no one knows about these observations. And the reason for this is because there's no real community. There's no one in charge. There's no central data repository for coastal data. Coastal data is, because it's relatively easier to collect, people use a variety of instrumentation. So there's no standardized methods. There's no best practices being implemented. And that really is the purpose of this task team, to develop coastal best practices for these under-resourced countries. What I'm going to present on now next is two initiatives that is closely linked to the observations best practice for under-resourced countries. And that is COLAB, which stands for Coastal Observation Laboratory in a Box. The PIs for COLAB is Greg Cowie, Juliet Hermes, which is also in our workshop today, and myself. And there's a long list of co-PIs, quite a few people from all around the world. And we are inviting people to join this initiative. And the next one I'm going to be talking about, and Catherine is here from the Fisheries and Oceans, Department of Fisheries and Oceans in Canada, is GEM in a Box, which is the Global Eutrophication Monitoring program in a box that I will also just briefly mention. So as I said, that's run by the Department of Fisheries and Oceans in Canada, who's the champion for the Commonwealth Blue Charter Ocean Observation Action Group. And it's a pretty new initiative. Okay, so on CoLab. So what is CoLab? It is to develop and promote low-cost coastal observing systems supported by innovative technology. So it's very good that Cedric spoke first, and I really enjoyed your talk, Cedric. And the whole idea behind this innovative technology is that it must be affordable, it must be transportable, must be trainable, repeatable, and very importantly, as the one member here asked, it must be collect accurate data. And there is a false perception that high-end facilities are required to do oceanographic research, like big research ships, very fancy laboratories and instrumentation. And we believe that very good science can be done cheaply and portably. And that is definitely required if we want to increase the number of dots in and around these under-resourced countries in our maps. Okay, sorry. So the objectives of CoLab is to develop an affordable and portable package of instruments and methods for standardized coastal oceanographic studies. And the idea is that they have maximum applicability, so you can deploy these instruments off a ship as well as off a dugout canoe in an estuary or anywhere. That you require minimal research infrastructure such as research vessels and laboratories, which most of these countries do not have access to. That they will be complementary to moored observing systems and remotely sensed data products, and that they must be easily taught and maintained. And the second objective is that we will develop best practices for the instruments that will form part of this Coastal Observations Lab in a Box, as well as training manuals, and that is where the Ops task team comes in. It's also our intention to secure funding for instrument packages, as well as a team to go to the various countries and train the people in how to use the instruments, how to maintain the instruments, how to analyze the samples, how to check and verify the data and upload the data into a central repository. The last objective I added there is a centralized database that will be adhering to FAIR principles. And we recently heard that NOAA is going to be assisting us in developing that. So the idea is, as I said, that these instruments can be deployed off any vessel from big ships to kayaks and dugout canoes. So the plan is that the equipment that we supply in these boxes will be modular, and depending on the need and depending on the capability and ability of the receiving nation or organization or NGO, depends on what we will provide. So from a physical oceanographic perspective, we are looking at providing in these boxes a basic CTD. We will definitely be looking at those open source CTDs that Cedric has been talking about, as well as current meters and a SekiDisk for turbidity measurements. Water sampling can be done with a basic old school Niskin bottle. And if you have larger vessels, we could provide a CTD rosette sampler. And if you've got big enough vessels, probably a winch to deploy those to deeper areas. So the idea is that you can use these equipments in anything from 0 to 200 meters depth. From the chemical oceanographic perspective, we will also be providing multi-parameter sondes for work mostly in estuarine systems, and provide a suite of simple analytical instrumentation such as spectrophotometers, fluorometers, and balancers. And just with those basic equipment and wet chemistry methods, one can analyze water samples for that whole suite of essential ocean variables. Additional equipment that you will need to do it includes a pump and manifold, a water bath, which is quite easy to build yourself with basic equipment you can buy from any supermarket. You will need sink, water, power, reagents, a refrigerator, and a freezer. And one of the scarcest commodities, I would say, in these under-resourced countries is purified water. So we will be looking at how to make purified water, but if push comes to shove, there are quite a few other methods that can be employed, especially in oligotrophic oceans such as the Western Indian Ocean. And yeah, we're looking at about a sample throughput of about 30 to 40 samples per day for the full suite. So from a biological oceanography perspective, it's quite easy to add a phytoplankton net in it, anything between 20 and 55 microns. And it's easy to collect the samples. It's quite relatively easy to preserve the samples, but to analyze the samples takes expertise and knowledge that is very scarce globally, let alone in under-resourced countries. But I'm sure most of you have heard of the planktoscope. If not, go and look at that website. It's quite easy to procure all the bits and pieces that you require, and we can build them and add them in these boxes. So we will be working closely with the planktoscope developers and designers and bring them on board as a partner for CoLab. So these images that you see there were taken with a planktoscope, not with a very expensive multi-million-dollar flow cam. Another equipment that we are considering, and Shirley Parker-Nance will speak about it a bit later, is stereo-baited remote underwater video systems. There was a recent paper published on the best practices for these BRAVs. They can be built, as you see in that top right-hand corner, using very basic equipment that you can buy in any hardware store, as well as GoPro cameras, and can provide really good data on not only the pelagic environment, the fishes, but also the inverts on the seafloor. But what would be ideal over and above collecting data at certain points or along certain transects would be to combine this type of work with in situ instrumentation, continuously recording data. And nowadays there are quite a few low-cost sensors or moorings on the market, such as Shoal. Spotter 3 is one of them. There's the open access marine observation system where we can, or anyone can really build their own in situ mooring array. So the idea would be to link, to also include in these boxes a whole system to include a mooring wherever they are collecting the rest of the biogeochemical data. All right, so that was CoLab. And the next one, I'm a bit out of my depth with this one, but if you have questions, you can ask Catherine. She is here as well. It is Gem in a Box, Global Eutrophication Monitoring Program. So as we all know, eutrophication is becoming a global problem, especially in coastal areas. And it is virtually impossible to mitigate eutrophication or come up with prevention strategies if you do not have a monitoring program in place. And the big gap here is that eutrophication monitoring relies on access to specialized laboratories, equipment, trained personnel, and substantial funding resources. Additionally, current monitoring efforts are not standardized or comparable across all the different initiatives around the coastline. So the solution was developed by the Department of Fisheries and Oceans in Canada, is this Global Eutrophication Monitoring Program in a box, which will consist of high quality, lower cost alternative equipment in boxes that can be shipped anywhere or put in the back of a 4x4 bucky and taken to remote areas. And the target audience would be researchers, resource managers, coastal resource users, policymakers, and it will be rolled out to Commonwealth nations initially over a period of 1 to 2 years. So the milestones for Gem in a Box, as I said, it's a reasonably new initiative that started earlier this year, but they're busy working on creating and deploying these gems in a box to some Commonwealth member states as part of a pilot study, which will, and the immediate benefit of that would be the collection of affordable, easy to collect eutrophication data from all these countries. At the same time, they will establish an effective data management system because most of these countries do struggle with data management and where the data can go and be kept safe. And that will ensure that the data is interoperable between the various member states and between the various sites. At the same time, they will start working on developing data analysis tools and visualization products, and that will enhance the dissemination and integration of this eutrophication data from various countries. The long-term goal basically is to improve our knowledge of eutrophication in under-resourced countries, and to ensure that the collection of data and information is sustained over the long term. So if you just look at some of the equipment that they are thinking of, you will notice that they are very similar to what CoLab has been proposing. So it's collection of samples, consumables, and to analyze the samples, and then the instrumentation they're looking at is very similar to CoLab. It is CTDs, it is Secchi discs for water clarity, it is spectrophotometers and so forth. And also, but what they've done very well, which we only picked up on lately, is a very strong data management system. And the reason why we're presenting these two together is that we have, in the past 2 months or so, started talking to each other between CoLab and Gem in a Box to see how best can we work together to ensure that we get the best out of both of these projects. And I think that's it. Thank you very much.
Thank you, Thomas, for this very interesting presentation. All those instruments in a box. I like the concept. Do we have questions for Thomas today? I don't see any question in the chat. There's one from Hassan.
Lucy, I can go ahead and ask the question to Thomas directly, if that is okay.
Yes,
sure.
Thank you, Thomas. This is great. Thank you. Thank you for sharing all that. My direct question very quickly here, do you have any concrete examples of this working so far? One is how successful to hire those folks out there to really take this box and do something with it. You know, and then continuity of the work. But then I think you already addressed the quality of the data and how we deal with that. I think you mentioned a few of those stuff, but I will just open it for discussion. Thank you.
Yes. Okay. Thank you, Hassan. Yes. So this has been effectively rolled out by the lead principal investigator, which is Dr. Greg Cowie from the University of Edinburgh in the Caribbean. It's worked very well there. We've presented this concept.
Greg is here.
Is Greg here? Oh, Greg, why am I giving this talk? Yes, and we presented this in Mozambique as well, and Greg went out and visited a few institutions and entities in Mozambique that are very keen. So our principle would be to, and we're busy looking for funding to fund these boxes. And we will go and look in the different countries for people that are interested to use it. So we don't have to hire people to do the work. We will find people that are interested in this instrumentation and that will use it regularly. Of course, it will involve quite a bit of on-site training and also follow-up training of these individuals. But what we found in under-resourced countries is there's a real need, and the people are very, very keen for us to be involved in this project and to run with this themselves. And you know, it might not only be government research entities or universities. There's a lot of NGOs in these under-resourced countries that do amazing work with very little equipment. And so I don't think we need to specifically hire people to do the work for us.
Yeah, Thomas, I thank you very much for the answer. I know that there is few people raising their hands already. I don't want to spend too much, but I think why I'm asking these questions because we're trying to do a similar thing with the fishermen, right? I mean, fishermen are out there 24 hours, 7 days, whatever, right? But then when you go to those countries, when you're talking about underdeveloped countries, there's always been challenge because they're always like, yeah, why you want me to do these things? They don't understand really the benefit of all these things. And so they push back on this instrument, even temperature sensor, even one sensor to put in their equipment, and then having a whole box of things, you know, the operations, what can happen to their operations are there. If we're thinking about fisheries to do this in fishermen's boats, whatever, you know, that's why I'm asking that question. It's really tricky. It's really tricky as you're trying to put these too many instruments. You might probably have to be prioritizing which ones. I will stop maybe here. I would let others to ask questions. Thank you.
Yeah, so Juliet just added in the chat as well, rightly so. We will co-design these boxes with each of the countries and the entities that we will be working with. So we will provide them exactly with what they would need to answer their research questions or management questions. But I'd take it. Yes, Greg, as a follow-up.
Yeah, I would just comment that as Juliet has said in the chat, that the idea here is that it's founded on all of these combinations of techniques, or a large percentage of them, the hydrography, so the CTD, the current, and the biogeochemistry, is modeled on stuff that has been done with undergraduates at the University of Edinburgh in a wide range of very remote locations, with various combinations of techniques. And I think that's the point here, is that, as Juliet has stressed, and as is the case with Geminibox alongside CoLab, is that the whole idea is that this is modular, that it's, if you want to be able to combine the CTD and current meter work with the whole range of biogeochemistry and biology, it's all doable with limited resources and not necessarily with a formal research vessel or an established laboratory. All of this has been done in the field. The laboratories have been set up in people's basements. So long as you've got running water and a bench, we've been able to do really good chemistry in very remote locations, you know, on islands 30 kilometers offshore with more spiders than humans by far. It is stuff that can be done. It can be done well and generate very reliable and comparable data. But the point is that we're looking to develop a modular system that, if you want to work in eutrophic systems, then Geminibox is your toolkit. And if you are looking to look in more oligotrophic waters, or if you want to look at the circulation, then other aspects of CoLab would be your toy box. So it's really meant to be something that you can pick and mix and use to fit the questions that you want to address. And I've done separate presentations that do give specific examples of the kinds of things that CoLab has been used for, and that has ranged from working in mangroves and very shallow waters out to all the way across the continental shelf, and those have been done without formal research vessels, and using the kind of line hauler and battery operated winch systems that you could run off a fishing vessel, for instance. So we're looking to get people's response and to fit with their needs. And indeed, we've worked with NGOs as well as universities, so in a variety of places. So just reinforcing what you said extremely well, Tom.
Thanks, Greg.
We have a question from Jay, and then George, and then Carla. So open your mic. We can't hear you right now.
Yeah, thank you, Lucy. Thank you, Tommy, for the presentation. I have a thought, and then I'd have a question for you. In working with certain of the fisheries folks, we've been asked, are there apps in a mobile phone? Because everybody has a mobile phone that could take temperature, that could do other things. And I don't know if you're doing this within the CoLab, but that would be one question. And the second question is, you want these to be interoperable, and yet you want them to be co-designed and you want them to be flexible. Do you have an idea of whether in the countries of limited infrastructure, we could create a business, or you're already considering it, that could produce modules or submodules that could then be distributed uniformly at very low cost, so that the interoperability and then the methods could be improved?
Yes, thanks, Jay. On your first question, we're not looking specifically at collecting data with cell phones at the moment, but the organization I'm working for have recently developed apps for the input of data. So when you are in the field and you collect data, you can have a system on your telephone that you can put everything in, and as soon as you're in Wi-Fi range, it'll load it up. So you secure your metadata, at least after each and every field trip. So we'll be looking at something like that, because everyone has a cell phone. And then to answer your second question, sorry, what was that on again?
The question was, is there a way to get low-cost production of your various items so they can be uniformly distributed?
Yes, so what we will be looking for is entities with the capacity in each of the regions. So at the moment, South Africa, probably our own institution will be the one for sub-Saharan Africa. And we will identify others in other areas as well. And those institutions will have the more advanced technology CTDs, like seabird CTDs, that are regularly calibrated in the US and so forth, against which these other instruments can be calibrated and tested. So that is the plan, that we'll have central areas from which equipment will be produced, developed, packaged, but also tested, calibrated, and if needed, maintained. I think that's a very good question and very important, because what has failed in all these countries in the past is the fact that there's no follow-up service and maintenance and training. Mm-hmm. So I think that is very important, that training continues basically on a yearly basis, because people also move from different organizations, and then you need to retrain, because if you don't, then the whole program comes to a halt.
Yeah, thank you.
Thanks. I don't know if anyone else would like to say something.
We may want to take two quick questions from George and Carla, and then we go to the next presentation.
So one is a compliment to everybody that's here, and wow, what an interesting thing. And Jace I know a guy named Neil that's going to pat you on the back. So I put a link in there, Neil Van Niekerk, and 2 Degrees C is an endorsed program. It's a small puck. I see somebody straining. Hang on, let me turn my. No. Oh, no, my mic is up. Anyway, so 2 Degrees C, I've known these guys like 7-8 years. They've been working. It's like a little tiny puck, and they're trying to jam as many sensors in it that meet Ocean Health Index standards to collect micro data. And then, yeah, it just Bluetooth plugs. So it's an endorsed program. And more almost ironically, Thomas, or is it Greg? Well, Tom, yeah, South African. Neil is South African also. So you guys need to plug in. I've just passed your guys, both Greg and Thomas, to Neil, but he's endorsed. He's part of ML 2030 that's endorsed. You guys are, I mean, there's 10 overlaps, I heard, minimum, between you where you guys are. So you guys need to collaborate, is my opinion. So honor to everybody here. And if we want to be a beta tester, because I have 25 teams that'll grow to 250 teams. And most of this came from the diving world by Sylvia Blue, 20 years going to DEMA. So I'll connect with you guys too to be a beta. I've beta tested for companies for the last 30 years. It's kind of one of my things. I'm also part of I was one of the 3 inventors of South by Southwest, and we will want to have you guys in an accelerator pitch there someday.
Excellent.
And I'll popcorn back to the moderator for the last question.
Thank you,
George.
George.
Yeah, thank you,
That's
George.
excellent. Now I think we're all convinced of the interest of those meetings, so we can get together and avoid overlaps. Thank you very much for your comments, George. So now it's for Carla. Carla, one quick question because we're running out of time, but please do.
Short question. Hi. So my question is, do you think about making a list about the supplies and parts that you need? Because sometimes you get an open source or maybe a box, but you don't get the supplies or to maintain it, even though they're different. And sometimes even though you have the money, you cannot get it because they are built abroad. So maybe I think the key thing would be to get like the most, I don't know, internationally common and replicable parts. And I think that will be easy not only to maintain, but also to build.
Yeah, no, exactly. Yeah.
Just one comment. That's why we suffer. I'm from South America, so I know what we are dealing with, you know?
Yes.
So, yeah.
All right. Greg, I see you unmuted. Do you want to answer that one?
No, I was just in case of. I think that between George's comments and Carla's, and I see questions in the chat as well. I think there's an awful lot to take on board here, and all of these points are good. It's exciting that there is the reactions such as George's and Jay's. I would say that in some aspects this is still in its infancy. The whole question of open source instrumentation such as CTDs and bringing those into what we do is very much part of what we plan, and that in particular is in its infancy. As far as maintaining, training and maintaining, we are putting together, we are making headway in establishing eventual teams for the training, both in the biological, the hydrographic, and the biogeochemical methods, so that it won't just be one-off. It will be something that we hopefully can provide ongoing assistance with. So I think that to answer a question in the chat, at this point, we don't have any reaction from established instrument suppliers, because thus far we are using, for instance, CTDs and current meters from established manufacturers. So we don't really have that problem yet. I think that in my world, at least, we are avoiding sensors to a large degree. We are doing basic CTD, and then in terms of, for instance, the biogeochemistry, we do it ourselves in a laboratory, and with old school methods of fluorometry and a spectrophotometer, which are just tried and tested, and anybody can do. If I can teach 3 undergraduates from my university to do 40 samples a day, anybody can. So
Thanks, Craig.
Yeah, thanks everyone. Really fruitful discussions. Shirley, are you ready to present?
Okay,
Just let me
I'm
say,
ready.
okay,
I'm
please
ready.
go ahead.
Okay.
And you can keep discussing in the chat if you want to. There are very interesting comments in the chat.
So I'm gonna go share screen. This one. Share.
And
I'm trying, getting there. I hope everybody can see the presenter mode. Nice big. Okay. I'm just gonna elaborate a little bit more on the benthic observations. Tommy did mention it as part of the collab package. This we developed here in South Africa. When I entered the world of benthic imagery, the normal equipment was very big and very heavy and very expensive. And through the years, at SAON, we were able to work with engineers and make these systems more cheaper, very robust, cheaper, but also smaller and lighter to handle, so that we do not need the big vessels or big winches necessarily to obtain imagery from the benthic environment. And currently in our box is a system that can be deployed to a depth of 60 meters from a small vessel, a 6-meter rubber duck by hand. I wouldn't pull it up from 60 meters, but it is possible. But generally we're working in a depth of 30 meters and less, and it is very user-friendly. So the first piece of equipment we have, and here we show you, this is the frame for the deeper areas. This frame can handle custom-made underwater housings that go up to 300 meters. And then I have a lightweight camera system I can put on that when we do have a vessel available, but that works on users' GoPros and over-the-counter GoPro housings. And then we can drop it down. On these, we're on bigger vessels, but we have made smaller collapsible frames that we have traveled with, and we deployed from any small diving vessel with 1 or 2 people. So this is the basic imagery we get from this. And then with the first object, or the first point we always try to make is to look in constructing large image, available image libraries, so that anybody can use these libraries to do the species or taxon identifications, but to reduce ramp-up time. So a person would actually just compare one picture to another for to identify species. It's a code-based system, so that as new species are described or unknown species are known, you can just put the right names to a code. The code stays stable, but the name can change. So we can always update old analysis done. And here's an example where we've done extensive testing on the quality of the data we collect, and we have made quite nice species databases for what is available off the South African coast. This also allows you to do basic basic libraries for the habitat itself, just to say these are seagrass habitat or reef habitat or boulder habitat, sand. This allows for very robust identification and description of the biotopes, and then looking at the community structure that is associated with these habitats. And then the second part of the analysis, when we are looking at not only the benthic invertebrates and algae or seagrass beds that is around, we also try and look at the fish fauna or the mobile fauna that is found in an area. And for this, we have stereo-baited remote underwater video systems. These are well-documented systems. Ocean Best Practice has a goose-endorsed Ocean Best Practice for how to use and construct these systems. We basically used this recipe and we made the systems. You can fold them up, you can put them in a box and you can ship them. Where it used to take a trailer and a large 4x4 bucky to have a stack of 6, move it somewhere where you want to go sample. These days I can put it in my very little French mummy car and drive it anywhere in the country. It is really compact and small, but still robust. So here you can see in the top picture, I just put this in to show you, this is about 30 of these systems lying on the floor as they were delivered. And in the lower part, we would have 6 systems that get shipped. So when they deployed, you deploy 6 of them at a time. They stay underwater for about an hour. You collect the data, you get stereo data. You can use open source software or board software and analyze this data to obtain not only relative abundances of fish, but also the size of the organism, because it is in stereo confirmation. So we have done extensive tests to see how we can use these, and if we can deploy the number of samples we estimated we can. And it's a really good system. It's robust. Everybody seemed to be able to handle it, and it takes about a day, and anybody knows how to use it, work with the cameras, look after them. So it's a very nice system to start and roll out, and we have sent them to various people to work with us. We do a workshop. We show how to use the software. We show how to do the data, and we are very optimistic that this could be a really good program to roll out as in a box systems. And this is just a video to show the quality of the data we get with the BRAF systems, where you can then count your fish species. Or this is not the tropics, so this is not very clear. This is Algoa Bay, where we have pretty turbid waters at times, and I think the video speaks for itself. Thank you.
Thanks, Shirley, for this really nice presentation. Thanks for this video, so we get a look. Bye. I think there's a question for you in the chat from George. George, you want to open your mic?
Did I put a question in? Well, again, really interesting. I would like to see, could I see I may have missed the first slide. The slide that shows, I'll call the device. I saw many of them in a box, but yeah, it's possible to share the screen again.
Yes, I can share. I don't know if I have one.
Or if you can just put a link in the chat to a slide, or paste the slide in the chat, that'd be great.
Yes, and and as I said, there is a very nice Ocean Best Practice publication that it gives you exactly how to make them, what they look like, and the parameters to use. So it's a
that'd be, yes,
recipe
please.
that everybody uses. So there's no worry about, everybody can make them and still follow the same recipe.
Great. If you've got that PDF or the link, that'll be absolutely stellar.
We will share that with you in the chat.
Thank you.
And George, you had you put a question about the AI for ID or manual.
And I'm going so fast. Yeah, I was curious when you were doing the fish identification and stuff. Is that AI? Are you using AI yet?
No, there's no, we aren't using it yet. There are developments worldwide to get it done. There are challenges, especially with turbid waters and lots of fish that overlap and swim in each other's way. So, but I'm pretty sure in the next decade, we will see the young folks make a headway, and these will be automated very quickly, and the data will still be there. We have collected it, and the reanalysis will be just so much easier and automated.
And did you have a ballpark price for a unit?
The units we use depending on the steel and the manufacturer, but the base price, of course, it's the GoPro over-the-counter housing and camera, which for the last couple of years have been around the same price. I think it's about $399 US. And if you wait a year, it goes down very quickly.
Well, that's what I said. Yeah.
And also technology. Some of the GoPros I've used is 12 megapixel. The next GoPro coming out is 23 megapixel. So it is just increasing. The technology is just getting so much better.
No, I was more interested in, I'm going to call it your structure, just a ballpark.
Yeah, the structure works to about, I would say, with the camera, with housings and the stainless steel, around 5,000 South African rands. Which, I don't know who wants to put, how much is that? Divided by 18.
Oh, okay. So divided by 20 is easy. Okay.
Yeah, so it's pretty cheap. Because it has a very long life. We've thrown them overboard regularly and not very gently, and they last. So
and are you putting? Did you say you're putting 4 cameras typically, or
6?
2?
We put
6.
6 of them, and then we do that 3 times a day. So it takes us about 15 minutes to deploy the 6. Then we wait, we pull them up, we change all the cameras, the batteries, the camera cards, and we deploy them again. So 18 to 24 deployments a day, or video streams, stereo video streams for an hour each.
Right. And you're just doing imagery right now. You're not putting any chemistry, science, or anything on it yet.
No, we have temperature loggers on each of the systems, so we can associate that with temperature, bottom temperature. But these stations that we do the benthic work on, the ILTER work here at SAON, is associated with the environmental variable stations, so the in situ stations, ADCPs, and temperature strings. So we can correlate that data.
I would suggest to you too, but obviously I'm sure you've already went, Thomas and Greg's stuff. I'm going to say Neil's puck for divers, citizen science divers, belongs, one of them on each one of these units collects micro data that's at Ocean Health Index specs. So, and they're going to be really low cost. So anyway, really interesting. This is all exciting stuff. Thank you very much for your presentation.
Pleasure. There's 2 more, Catherine and Hassan.
I think Hassan was first.
Yeah, no worries. I think George just touched base on that, because I was interested also in AI and machine learning, and I just shared with you, Shirley, if you're interested. We've been funding a lot of this work, at least to address the processing of this data, because it's become very hard. And one of the challenges is really to put this data somewhere.
The size. But the data, it's almost like a home loan. The further we go on in life, the data becomes actually smaller, because our capacity becomes bigger to actually store the data. So I think yeah, it's big data at the moment, especially the video data. And if you retain all the videos, I know that some institutions only retain either images or part of the videos. Currently, Seance still retains all the videos that plan to take all the, save all the videos. But yeah, it is a big data layout to, yeah, keep that
Yeah,
all.
I would say probably AI on the box too.
Yeah,
I'm in the box, and the AI in the box as well. So real-time processing of those videos would be something anyway. That's
yeah, the real-time,
a dream come true.
Yeah, it takes about 4 hours for every hour of video that has been collected if you want to do all the species and do the size measurements. So it is quite labor intensive at the moment.
Yeah. Hey, I'm gonna be rude and ask Shirley, are you doing other species besides fish? Are you doing reefs and corals, sponges, aquatic plants?
Yeah, with the jump camera or drop camera system, we take off any substrate, especially reefs. I'm a acidian and sponge taxonomist, so I specifically interested in those as well. So we have large databases of the species, and then we try and help people to be able to identify these, because in South Africa we still have a good 30 to 40% of our reef that has not been described, the species. So it is it's very diverse, and there's not a lot of taxonomists around. So
Excellent. And I think the eDNA sensors are going to be interesting on this too. Maybe that's what you're doing with the water you're collecting. eDNA.
It has. There are scientists doing the eDNA specifically for the soft corals and sponges around to see, but also for fish species.
Right.
So that there is lots of interest in that, and we have collected, some of our colleagues have collected samples specifically to look at eDNA and correlate it to what is growing on the reef. So yeah, that is an field of interest. Catherine?
And I think we have one question. Yeah.
Okay,
sure, great. Thank you, Shirley, for the presentation. It's super interesting to hear about. As someone that used to do a lot of field work sampling fish, I know the challenge of identifying and collecting fish. And I was wondering, do you find any limitations with the GoPros for nocturnal species? And I can totally see the benefit for cryptic species, and there's definitely a challenge with any species of mangroves or any kind of entanglement. And I was wondering, how do you find the resolution, especially combined with AI identification for nocturnal species?
I don't think they have done much because it is so low. The quality is quite low for the nocturnal species, especially looking at what lights to use. There is a big does white light influence the behavior? It's better to use blue lights or red light in that circumstances, and then of course your visibility goes down, and that makes things more difficult. Currently, our work is only in daylight, so the shallow water systems actually works without lights. We don't actually use any light for them. And we have colleagues that work in the deeper habitats, and they have successfully used lights and use it in very deep habitats. So it's not impossible, but it is a challenge for AI, I think. And already just in daylight, with the turbidity of the water and the movement and the currents, it's already a challenge. But I think this is something that the new scientists will, especially the ones interested in programming and AI and stuff, will find a solution for. I don't doubt it. I mean, and so we try and collect the best quality data we can, so that it is available for future. We keep that in mind, that that will happen, the automation. So we try and do the best quality we can for the costs, and good quality for frugal, to make it cost efficient, but also that you can get enough data to actually make usable, not just a single deployment with a very high end camera that takes a whole ship. It's a compromise. But we for the work we're doing at the moment, we find it's very accurate. We have developed smaller. The bigger graphs have a separation of 70 centimeters between the lenses. These smaller ones we use here is 50 centimeters, so medium-sized fish or populations. I have also developed, with other colleagues, a really small one we call a little froggy. It's about 20 centimeters difference between the GoPro cameras, and we are able to measure a centimeter fish, baby juvenile fish in seaweed and in seagrass. So we use that to look at nursery areas and seascape connectivity research that we do in the shallows. So I think each of the graphs have a place, but the medium size, the ones we have here for in the box, and the larger ones, they all follow a single ocean best practice recipe. So it makes the data comparable. So yeah, I'm very happy with the research we finally get.
I see. Okay, thank you. Thank you so much.
Okay. Okay.
Okay. Jeton, can I hand over to you for some housekeeping, community building activities?
Oh, yes. So we have a survey that we would like to advertise, just so we can get a better idea of the limitations and the needs of the community. I just need to find the link quickly and I'll post it in the chat. It shouldn't take more than 10-15 minutes to complete the survey.
Okay.
Sorry, Lucy, carry on.
How about we take a group picture while you're searching for this link?
And then just George, I see my husband actually posted that field annotation guide in the chat. So you can just look at what Tim posted in there.
Oh, excellent. Thanks, Tim.
Thank you.
We're doing quick photos. You need to be in.
Yeah. Well, Jeton is looking for a survey. Thanks for this conversation and discussions.
Okay.
Okay. Let me display my screen. I thought we were 22 at the top audience, but we're still nice. Okay. When I count to 3, you can smile, okay?
I have the sun behind me. I'm trying to avoid the sun, get away from the sun.
It's good to see you guys. Okay, 1, 2, 3. Let me just take one more, just to be sure it's fine. 1, 2, 3. Perfect. It's frustrating not to get a chance to know you all. So please take a look at the notes. You know, we have a Google Doc to take notes together. I can resend, and you can put all your information, like contact information, in this document. And yeah, that will help us just to keep track and maybe to engage one-to-one conversations. Thank you. Jason, do you have the link for the survey?
Yeah, I've posted the link in the chat. Yeah, if you sign up, or if you sign up on the website or in the register in the Q chat, we can send the link and any other information like the presentations to everyone. So please sign up somewhere. And yeah, thanks everyone for attending. I don't know if Lucy, if you want to add anything. But, yeah.
Well, Jay has a comment in the chat. Maybe Jay, you want to share your dream with us today?
Yeah, I'd be happy to, Lucy. I've been looking at the Argo system and thinking about, boy, it would be really nice to have a very cheap, pervasive float system that could be for coasts. And if you lose it, that's fine, and it should be edible by fish or maybe degrade. But it would include the key conditions that we worry about in the coastal environment, whether that's temperature, salinity, etc. And it would feed data back through the mobile phone network because we are dealing with coast as much as we can get it. And I'd sure like it to be, you know, very, very inexpensive. I've seen some of these floating around, but we're taking in Colab and Gemini Box a new approach, a very important approach. And I'm wondering if we could apply that to very low cost floats.
Guy, I shared with you some of that dream. Maybe you probably know it already. So that's something interesting. Thank you very much for, you know, that dream. It's good to, yeah.
Thanks, Hassan.
Yeah. Thank you.
Jay, I put some. Yeah.
The drifter program, we're developing drifters that were biodegradable. I don't know if you've looked into any of that. I can track down the information and share it with you.
Yeah, let's create a local place to put all of these links and things. Maybe as part of the task team, Lucy, we could have just an aside for low-cost coastal floats and see what we can do. Is that okay?
Yeah, it is. And this is a nice opportunity for me to remind people that we're building a website where you can share your initiatives. Let me share my screen again. That would be a nice conclusion to these sessions. We had one more presentation, but we have the feeling we won't have the time to play it. It was a recorded presentation, so I'll put it on that website. It was about an ocean acidification program. Really nice presentation from Carla. She did a great job recording it. So I'll put it there. I don't know if you remember the link to this webpage. Let me put it in the chat, then I'll share my screen. There.
We do have another 2 sessions tomorrow, and we will play the recording.
Yes.
Then, so if you are interested.
Yeah, for those who register to all of our sessions, well, thank you very much, but we'll be like the same session 3 times. So maybe, well, you'll have Carla's presentation, but you will be able to find it there. We'll put all those initiatives. And Jay was mentioning Cosmos, the Cosmos project from Ifremer. This is a low-tech open source camera for fish identification. So we'll put all those initiatives there. Now you see Colab and you know what it's about, and you have Gemini Box. And when we started this session, we asked people to join our community, and we can see that we were 2 at the beginning, and now we're a little more than that. So please keep on joining our community. As you can see, you can like answer quick questions like, would you like to join our activity? Would you like to be informed? You can subscribe to a web mailing list. And yeah, we'll keep on sharing resources with you guys. And if I will have like 2 more minutes, I had some, well, I won't play the whole presentation, but I just wanted to advertise about this citizen science program. Can you see my screen? Okay, yeah. This is like educational passages where students around the world prepare, deploy, and track their own very own mini boats while learning about the ocean current, weather, technology, and more. I'm not sure it's biodegradable mini boats, and we'll make sure we can make connection between this and the Colab and all those in a box devices. And I'll take a few more minutes to share with you this other initiative from Argentina. See, Carla, I don't know if you heard about this self-managed monitoring program for coast. This is Gerardo Perillo who's running it. So it's all about developing local sensors. You see conductivity, temperature, some optical sensors, wave sensor, wind sensors, acoustic profilers, built by researchers for researchers. And they're doing this training program for students, for fellow, so they can train people in their country. So please look for more information. And I think I could stop sharing right now. And if others have some questions, some comments, some suggestions, so we make this presentation, this session better tomorrow, please do. We have a few more minutes to do so. No. So yeah, Jay?
Lucy, one of the things that is needed here is stable funding and therefore good visibility to the funding communities, whether they're governments or philanthropic or et cetera. And I'm wondering whether something like Collab or Collab, Gem in a Box, et cetera, could be put together as a project under the Ocean Decade to give it more visibility. And I know there is Coast Predict, but the OBPS has an Ocean Practices Decade program, and it's a natural fit also there. What do people think generally, of people in the room, think about this idea?
Well, Jay, that's a great idea. I mean, I think it fit well.
Excellent. So
Yes, maybe I could also just answer, Jay. So we prepared a 3-page proposal for Collab that is currently circulating within the Commonwealth program. So hopefully we get some success there, but we are also part of the Decade Coast Predict project already. It's both the task team and Collab, which is excellent. But yeah, it's a good idea. I think so. We definitely need funding to provide the equipment. We cannot expect these under-resourced countries to buy the boxes themselves.
Only problem, Thomas, that UN Decade is not going to pay you the bills.
No.
So yeah, it would be an interesting
Yes.
program, but again, it will maybe, at least you would be in the table to hear what's going on in terms of funding and all that. Maybe that's what I. Yeah.
Thanks.
Thomas, if you can share George Cowie email would be great. Thank you. I missed it.
I
So.
think it was,
No.
it's Greg Cowie.
Oh, Greg. Yes, Greg.
Yeah. Another name with a G.
George, Greg, thank you.
Catherine.
On a different topic, one comment that I just wanted to mention in representing part of the GEM project too, and still being in the concept phase and designing the prototype, is that these sessions are really great to hear everyone's feedback from different experiences, what could be prioritized and what are the challenges faced in different areas, because we definitely realize that the challenges and priorities of one area might be very different for another. And so we definitely welcome feedback on what to prioritize. I also see a lot of similarities to the citizen science work that Cedric is doing, and would be really interested to hear about the platforms that you use to advertise these tools, and also what are the challenges that you face with citizens taking out those tools, and what are the apprehensions that you find those citizens have in wanting to take this on, because I think that's some of what we're facing a little bit too in wanting to advertise and recruit partners to help with the development of the box. So I'm really interested to talk to all of you and hear more about these citizen science projects too, and how they're received, and what some of the challenges and the unexpected kind of obstacles are in handing these things out. So thank you so much for the session. It's been really informative. And I love the representation. It's very diverse in this session too.
So Catherine, I just will say something here very quickly. I think one thing that can be done is to show the benefit of this data, not just deploying sensors. I think I mentioned it in the chat many times now. I think what will drive this initiative to move forward is we have to show the benefit of this data, how this data is changing the world, okay? If that is not done, that would be very hard to sell the idea forward. And so we have to make sure we have some, let's say, pilot project or case studies where we can show the benefit, how we take in this data, putting it in some kind of tools, ocean models, or some other things. I mean, coastal area is the most important one and the most blind for us all the time. I mean, from satellite, from everything. So I think to show the benefit for ocean modeling, coastal ocean modeling, or for other societal benefit will be a key to moving forward.
Yeah, thank you. I very much appreciate the comment. And it's definitely our desire, I know, along with CoLab, to work with the countries and to not force these tools on them, but for them to also to see a benefit.
Yeah, do we have any other questions or comments or points of discussion? Yeah, if not, then yeah, thank you everyone for attending. Thank you to all the presenters. Yeah, it's been a very valuable session for us, and I'm hoping for you too. Yeah, thank you very much. And we do have another session tomorrow, another 2 sessions tomorrow. So if you are interested, please feel free to join us. Yeah.
First section is, I think, next section is at 6 GMT, 6 a.m. GMT.
Yes. So, yeah.
But thanks for attending this one. It was our first session, so thanks a lot.
Thank you.
And a good year.
Thank you, everyone. Bye-bye.
Thanks, everyone. Bye.
Bye.
Jane.
Have a lovely evening. Bye-bye.
Bye, everyone. Really good.
Bye.
Thanks. Bye.
Lucy and Jetam, can you stay on for a second?
Sure.
Yeah.
Super. Part of the process of sessions is to have a session summary in the daily newsletter that we put out. And I don't know if Pauline mentioned that to you. I know she was watching. It's a paragraph, not much more than a paragraph. And it summarizes the key points of discussions, and then we merge the different session reports. Could you do that before you go to sleep tonight, or before
tonight? Because
oh yeah, it's only a paragraph. 5 sentences, 6 sentences is quite sufficient. But
okay.
we do send it out.
But don't you want us to do that at the end of our 3 sessions? Because we'll have to tonight.
No, the reason is that by putting it there now, people will see it. They may come to the next session or the one after.
Okay, we'll do it then. Will you be attending tomorrow as well? Because you always have great questions.
Oh,
but maybe it's too much asking.
No, I have a problem, Lucy. My heart is here, so you know that. First of all, your session is at 4 to 6 in the morning for me.
Oh yeah.
And then worse than that, I helped organize the ocean forecasting session, which is at the same time.
Oh.
So I've got a conflict, and you have the third session. When is it?
It's at I think it's 11 a.m. GMT.
Oh, okay. So that's 2 o'clock in the morning for me.
Okay.
So
no.
But I love it. This was a really good session, and what I'm really hoping, and I was having a private chat with Juliet, is that your group has a project with the Coast Predict, and I'm in Coast Predict on the steering committee, so executive committee. So I like that a lot, but I think the task team and the work that you're doing should also get exposure through others. And I wanted to just encourage that you take the application you put into Coast Predict, modify it slightly, and submit it in the current cycle to ocean practices?
I
know.
had a conversation with Patrick Gorange, you know, from SMHI,
know Patrick
Sweden.
well, yeah.
And Patrick is all about low-tech technologies and citizen science. We are together within the Atlanta Steering Committee, the ones that prepared, you know, this low-tech session. It was really successful. And Patrick has a conversation with Nadia Pirnardi from CosPredict, and Nadia asked him to be the chair of a section of CosPredict that will be dealing with low-tech and citizen science projects. So we may want to apply, but we also have this group within CosPredict with a high exposure, because Nadia is expecting also a lot from low-tech and citizen science regarding the coastal observation. So I think we've got the energy, we've got the people, so we're good to go.
Yeah, and are you going to propose that as a project then under CosPredict?
Yeah, I think we will, but I will discuss the strategy with Patrick because he'll be in charge of that. And yeah, Nadia wants him to run that. And I'm not sure if she wants him to run that as a project or as a sub part of CosPredict. I need to figure that out. But
it's probably
when is the
both.
deadline?
I don't know, a month or so. You need to look it up.
Lucy. Yeah, we will.
Two comments. Each of CosPredict has 6 focal areas, focal point areas. What you're talking about is 3. One does the predict on time, the hazard response. 2 is the climate. 3 is the one you're talking about. 4 is health. 5 is infrastructure, which is mine. And then 6 is capacity development. And so what they do for each of these focal areas is a core project is submitted through the decade, which is then submitted to CosPredict, and the CosPredict then uses that as the means. So we have a.
Oh, thank you for clarifying this point to me.
Yeah, no, it's fine. And we have them for FA 1, 2, 5, all have core projects already, but 3, 4, and 6 do not. And so what you're doing is really working on 3. And I think that's super.
Okay.
If you submit it, you're allowed to submit simultaneously to 2 programs. In other words, the same application can identify 2 programs. And I'll talk to Nadia about that. And I'm encouraging you to deal with the best practices in citizen science and the low-cost sensors and things more visibly. I'll stop there. I've said enough. Just think about it.
Thank you very much.
Yeah, thanks very much, Jay. Your inputs are always valuable and welcome. Yeah, thank you very much.
Thank you, guys. Good session. I'm really pleased it worked out well. You have a good evening.
Oh, thanks.
Thank you, Jay.
Thank you. Bye. I'll meet you then. Bye.
Okay.